Hi, Gil from Testing Gil here, and today I want to talk about the S in SFDIPOT. If you missed the primer on SFDIPOT, it's a test strategy heuristic, you can watch it here. When I started my career as a developer, I was told to never talk to the testers. Really, those were very strange times. The reason I was given is that if the testers knew how I wrote or developed my software components, they would not be able to test the software objectively. Now, I can guarantee you that no one tests objectively. Even the non-humans who run our tests have their own bias of the people who wrote them. It goes back to black box testing, which says you need to test the system regardless of how it's built. It needs to work as was specified. Which makes sense until you remember what the goals of testing are. It's not just validating requirements. It's about collecting and reporting as much information as we can to stakeholders. It's about finding out about systems behavior by poking it where it hurts or tickles. We need to know where to probe. Sometimes it's from the outside. Sometimes it's from the inside. But for that, we need to know how the inside works. How is the system built? And how does its structure impact our testing? Let's take a look at a couple of examples. Let's say we're testing APIs of a CRUD application. The APIs of our Bigger Better Bookstore app. Creating a book, updating its details, deleting it. If we're taking the black box road, it doesn't matter how things are written or developed or built behind the APIs. But what if we knew it was built like this? Remember the poking and tickling bit? Once we understand the structure, we realize that with a distributed system, a lot of things can happen, like timeouts and disconnects. So we have uncovered a way to probe the system and see how it reacts to these things. How do the APIs behave if the database is disconnected? Does the system fail? Does it return a very detailed report? Retries after a while? Understanding the structure leads us to cases we'd like to test. It also gives us ideas how to design these tests, so we can learn more about how the application works. Do you want to confirm the APIs work as intended functionally? That the pieces of code just work together? Then you can design your tests to run everything on the same box. Now, what can that tell us? If the same box tests fail, that means there's probably a problem in our code and not in the environment. But if they pass and we run the same tests on a distributed environment and they fail, now we know there's a problem with the configuration. Let's take another example. Logging of diagnostic information. Every app logs a lot of information. Not as a feature, but more for monitoring or debugging. We seem to take logging for granted, but logging can have a real impact on the system's behavior. Let's say we know the application is running on a real server, not a virtual one, and the logs are kept on its real drives. If we know this, we can ask questions like, do the logs get deleted? What happens if the logs are not deleted and the drives get clogged? Does it impact the application performance? And what happens when we run out of drive space? Then we can design tests to check this behavior. We can then report our findings to the stakeholders and they can do something about it. Knowing the structure of our software and how it works can lead us to ask questions. Then we can turn those questions into tests. Finally, we don't have to run every test that we thought of. As with every test that we have, and with SFDIPOT we'll have a lot of test ideas, we can later prioritize what we actually want to learn and what to actually run. And that's the S in SFDIPOT. Thanks for watching. If you liked this video, like, subscribe, and watch other videos on the channel. And in the comments down below, tell me about how your knowledge of how the software works gave you ideas of how to test it very cleverly. Until next time, bye-bye.